The CHISQ.TEST function in Excel can perform a chi-square test for independence and for goodness of fit. In both cases, the function is CHISQ.TEST with the actual range and the expected range specified. The test of independence is based on a two-variable contingency table, such as this one. This is a 2x2 table, but the same process applies to any two-variable table with multiple classes per variable. The null hypothesis is that ice cream flavor preference is independent of age. The alternative hypothesis is that flavor preference and age are not independent. The actual range, usually called the observed values, and the expected range, usually called the expected values, can be entered in Excel with or without row and column labels and marginal totals. The expected range is the row total times column total divided by the total number of observations for each cell. This can be performed directly in Excel or calculated elsewhere and entered as cell values. In this example, the observed and expected values are adjacent, but there is no requirement that the tables be in any particular place. The chi-square-test function is chi-square.test. Neither the statistic nor degrees of freedom are shown, only the p-value for the test. In this case, the p-value is 0.03788. The chi-square-test statistic can be recovered using chi-square.inv or chi-square.inv-rt. The input to chi-square.inv is a probability and degrees of freedom. The probability is 1 minus the p-value returned by the chi-square test. The degrees of freedom is 1, since the table is 2x2. The value returned by chi-square.inv is 4.31, which is the calculated chi-square statistic. The input to the right tail function, chi-square.inv.rt, is the p-value returned by the chi-square test. A test for goodness of fit compares an observed probability distribution with a specified probability distribution. The null hypothesis is that the distributions are not significantly different. The alternative hypothesis is that the distributions are significantly different. The usual example is comparing the actual outcome of rolling a die with the expected outcome. The expected distribution is an equal frequency of values from 1 to 6. This is the observed and expected table in Excel for rolling a die 30 times. For the test, only the observed and expected values for the two distributions are needed. The die face column and the row and column labels are unnecessary. Also, the observed and expected columns do not need to be adjacent. The only position requirement is that the rows correspond. The test function is the same as for the test for independence, chi-square.test. The input is the observed column and the expected columns. The value returned is the p-value for the test, the area to the right of the chi-square test statistic. The area to the left of the statistic is 1 minus the p-value. The CHISQ.TEST statistic can be recovered using CHISQ.TEST or CHISQ.TEST as explained above. This test has 5 degrees of freedom. For this example, the CHISQ.TEST statistic is 4.